Hello and welcome back to Apt for You. In this particular video we'll be discussing a new problem, right? So the problem is find the duplicate number. Quite interesting. This problem I have picked up from LeetCode and I'll be solving it there. So we have to find the duplicate number. So basically the problem says that you are provided with an array of size n+1, which means if n is equal to 4, you will be provided with an array of size 5. So basically I have 1 2 3 4 5 cells, right? Now the elements in this array, or the elements of this array, will lie in the range 1 to n only. Means whatever number you fill here will be in the range 1 to 4, between 1 to 4. Although there are 5 cells, but the element here will have value between 1 to 4. Like you have 1 3 4, and there will be only one element which has occurred multiple times, or whose duplicate exists. For example, suppose here 1 3 4 2 2, you can see that okay, all the elements are satisfying the constraint that their value is between 1 to n, true, and there is only one element whose duplicate exists. So basically you can see two duplicate are present. Now the point of confusion can be, now here you can see there is only one duplicate of 2, right? But this is not the only case. There might be conditions when you have 1 2 2 2 and 2. So you can see this array also satisfies the constraint because all the array elements lie between 1 to n, and there is only one element whose duplicate exists. You can see there are only duplicate of 2s. This is also a condition. So your problem should be able to detect this also, that which elements duplicate actually exist. So given an array of integers nums, basically this is the array, and it has n+1 integers where each integer is in the range 1 to n inclusive of 1 and n. And there is only one repeated number in nums. So in this particular array there is only one repeated number. Now maybe it is repeated twice, thrice, or the entire array is filled with that number. That is also possible. So we have to return that repeated number. So one thing they have basically said, that there is only one number which is repeated. Now how many times it is repeated, it is not known. So you must solve the problem without modifying the array. So that's it, we will not modify the array, and we have to use constant extra space. Is it possible? So alright, let's see. So quite a challenging problem, quite interesting also. So one of the approaches can be that, suppose I have the array 1 3 4 2 2. What can I do? I can basically sort them. After sorting, I will get the array as 1 2 3 4 4, and then what will I do? I will basically start traversing this array from starting to end, right? What will I do? I will check if I is equal to I plus 1 or not. The moment I get I equal to I plus 1, then I will stop. So here it is not there, so basically I comes here. I equal to I plus 1, false. So false, false. Continue. I equal to I plus 1, false. I equal to I plus 1, true. Or even, sorry, suppose this is the element 1 3 4 4 2. Suppose 1 3 4 4 2 is my array. So you see, after sorting it will be 1 2 3 4 4. Now you see I not equal to I plus 1, I is not equal to I plus 1, I is not equal to I plus 1, but this time I, which is pointing to this particular cell, is equal to I plus 1, that is this cell, which means the duplicate is detected, and hence we can return that array element. Got the point? So let us implement this particular problem. So if I implement this, so basically what I have to do, first of all I have to sort what? The nums array. So nums dot begin, comma, nums dot end. After successfully sorting it, I'll just run a loop. I equal to 0, I less than nums dot size, alright, and I'll say I plus plus. So basically I'm just going to traverse the entire array, and within that what I'm going to say, if array of I becomes equal to array of I plus 1, got the point? So it becomes equal to I plus 1, then what we can do, we can just say break, and what we will return at that time, you just do break and you just return the array of I. That's it. I'm sorry, not array, actually the array name here is nums, right? So you should write nums, nums, nums of I. So this will also be nums of I. Got it? So yeah, that's it. So let us run this code. I have already tried various ways of solving this, so that's why it was showing accepted. Yeah, so this particular code, you can see this is also accepting this particular test case. Now let us just submit it. So if I just submit the code, I was trying different approaches to solve this particular problem. So yeah, So this approach basically works fine, right? So this particular approach, they say, what are the statistics say? Basically, runtime took 120 millisecond, and it is faster than 41.39% of the C++ online submissions. Fine. Memory usage 61.3 MB less than of C++ online, 50% of C++ online submissions. So can we make it more better? What is the time complexity of this process? Order of n log n, definitely. Why? You see, we are using sorting. By the best algorithm, it will take order of n log n to sort, and then hence only one traversal. So order n log n plus order n, which is the dominating term, order of n log n. So basically time complexity of this is order of n log n. Talking about the space complexity, we are taking constant space. Got it? Can you improve this particular technique? Yes, we can improve this particular algorithm, and we can improve, or we can just move on to a new very perfect algorithm to basically find out this in constant space and linear time. Can you do it? Yes, we can do it. Let's see how. So the idea is to exploit the fact. So now see, we are just not paying attention to this fact. What is the fact? The fact is, they have clearly mentioned that the integer is in the range 1 to n inclusive, right? Whatever integers are present in the array, that lie in the range 1 to n itself. So can we exploit this particular fact? Yes, we can exploit. See how. So let me just reset this. Okay, so you see, we have an array of elements like 1, 3, 2, 2 and 4, right? Alright, so let us see what they have written. Let us write that only. So they have basically provided us with an element array 1, 3, we have 4, we have 2, we have 2. Got it? So this is my array. Fine, so please pay attention. Now these are the array elements, right? So what should I do? Focus on their index. So if you just focus on their index, the index is 0, 1, 2, 3 and 4. Now the algorithm that I am going to use, now you see, whatever is the index, the elements in the array belongs to one of these index only. Getting the point? The elements of the array, like 1 belongs to the index, 3 belongs to the index, 4 belongs to the index, 2 belongs to the index. Got the point? So I hope you are getting the point that what the elements of the array are one of the index of the array, right? We will be using that particular property, or that this particular phenomenon to basically solve this particular problem. Now how? We are going to traverse this array basically from starting till end. Throughout the array we are going to traverse, and during traversal what we will see? We will see this element value is 1, right? So we should point to the 1 index. Value is 1, so if I am in this position, the value of this element is 1, so nums of 1 will give you 3. Make it negative if it is not negative. I am making it negative. Now come to this element, take the absolute value of this. Absolute value of this is 3, so it will point to this index. So this index, the element is 2, make it -2 if it is positive. Come to this index, come to this element, right? I have traveled here, I came here. 4, go to index 4 and make this element negative. Come to this element, take the absolute value of this if it is negative. -2 means index 2. Go to index 2, make the element negative if it is not negative. Negative. Come to this element, -2, make the absolute value is 2 to move to the index 2. Now if you find that, now you know that we are going to make it negative, but if we find that the number here is already negative, what does it indicate? It indicates that this cell has been visited earlier, right? This cell has been visited earlier. By which number? By the number 2. And now this, again, next time when I am meeting -2, the absolute value of -2 is again 2, so I am referring to index 2. Index 2 has got element -4. Minus indicates this element has already been visited. So this indicates that this element that we are going to visit, this 2, repeats, or its duplicate is basically present. I hope you got the point, right? So that's why we are going to code. So let me just erase this and explain you again. So I'll be having elements like 1, 3, 4, 2 and 2, right? So let me just draw the array. Cool. So this is my array. These are the indexes, okay? 2, 3, 4. Now let me code. What I'm going to do, I'll be taking the help of only one variable, integer I, for traversal. And what I'm going to do is basically I'll say for I is equal to 0, I less than n, I plus plus. Just go on traversing. While taking the value of one more value, that is v. Suppose val or v. Val, okay. Now I will first of all find out what is the value of this nums of I, right, and I'll make it absolute first. Okay, first I'll find out the absolute because I'm going to use it for indexing, right? So value equal to absolute of nums of I. So nums of I right now is 1. So val is equal to basically pointing to 1. So now I'll say if nums of val is less than 0, we will break, which means the number is already negative, means this is our second visit, and this is our second visit means it is a duplicate. Otherwise what we are going to do is basically we are going to say nums of val is equal to -1 into nums of val. Now let's see how it works. So let us understand it's working. So this is the code, right? Now you see this is the index 0, 1, 2, 3 and 4, right? Let me write it with a different ink. So different ink in the sense, let me write it with let's take this 0, 1, 2, 3 and 4. Now how does it work? So basically I will be starting from 0. I am here, so this is my value of I. Okay, I is right now here. What will happen? Now you see this is the value row. Okay, when I is at 0, the value will be equal to absolute of this element. Now, absolute of this element will be 1 only. Absolute of nums of 0, and this is the nums array, right? 1. We will check if the element in this nums of 1 in this index is negative or not. If it is negative, it indicates it is my second visit, right? So we will break. Otherwise we will make it negative. So nums 1 is nothing but 3, which is positive, so not negative, so basically make it negative. I made it negative. Done. Now I comes to this index. What is the absolute value of the element at this index? 1. It is -3, so absolute value will be 3. So I should focus on the index 3 and see if the element is negative. The element is not negative, it indicates this is my first visit, so no problem. What will I do? The element at this index, I will make it negative if it is not negative. Done. Now I comes here. Absolute value of the element at second index is basically 4 only. So now I will focus on the index position 4 and see if the element is negative or not. The element is not negative. If the element is not negative, I will make it negative because it is my first visit. So I will come now here. The absolute value of the element at this index is -2, and -2's absolute value will be 2. Basically they are trying to say that just focus on the index 2 now. If you focus on the index 2 now, the element is not negative, which means it is my first visit, so make it negative and move I forward. Now next time again my element here is -2, absolute value will be 2. Now it is indicating that move to the index 2. If you move to index 2, you find out that the element is already negative. You see, if nums of val, so nums of 2 is basically negative, it indicates this is my second visit, so we will immediately break. The moment you break, what will happen? You will come out of this for loop. Here you will come out here. Once you come out of this, what should you return? You should basically return this val. Writing the point, return this val, because this indicates my duplicate element. So I will basically say here return val. Okay, so let's compile this code. So I hope you got the point how this is working and how we are able to solve this particular problem in order of n. Okay, n is not given, fine, it's okay, not a big issue. So we were basically taking n. Now what will be n? N is equal to number of elements, right? Number of now size -1 basically. So size will be nums dot size -1. This is the value of n, isn't it? That's it. Let's run it. So yeah, the code is accepted, it works fine. If you submit the code, you will find that it works better than the previous approach. Okay, some issue again. Let us see what is the issue. What's the problem? Alright, the error is, I think we are writing nums.size -1, right? And then again we are doing less than n. So what is the point of doing that? So basically we should write less than equal to n, so that it will take all the elements from 0 to nums.size -1. Now it should work fine. So a silly mistake. Yeah, the code is accepted. Let us submit the code. So yes, now you should just see this particular problem basically I was able to solve this in linear time, right? Time complexity of this particular approach is order of n, and you can see it is basically 96 milliseconds as compared to the previous approach which took more than 120 milliseconds, right? And it is actually faster than basically 71.20% of the submission. So doesn't matter. Memory usage is almost same, right? Basically here also I am taking constant space, but the only difference is the speed. So basically I was able to solve this in linear time, and the previous approach it took order of n log n. So I hope this video was helpful. In case of any doubt, please feel free to put it out in the comment section. Just like, share and subscribe. Thank you.